So for this problem, we're being asked to perform the indicated operations and simplify. So these problems are essentially testing us on if we know our exponent laws. So for example here, when exponents are being divided, in reality they're being subtracted. It could also be seen as x of n over x of m. In reality, it's x n minus m. So what I'm going to do here is simplify the 5/15. Be 1/3. And I like to write this out separately. So it's going to be and then this gets a little confusing because there's a lot of negatives. But it's -4 minus -2, which in reality this turns into a plus. So then we would get y to the -2 power. And even if we get a negative, it's still going to go on the numerator. That's just one of the rules. And in order to undo a negative exponent, you have to move its location from the numerator to the denominator, or if it was in the denominator, from the denominator to the numerator. And that would be your answer. Okay, for the second one. Oh, I think I copied it wrong. So both of these are negative. No, just the 3 is negative. So we're gonna start inner layer, working our way out. So before we can convert this negative exponent to positive, we have to worry about this. And like I said, we're gonna do the inverse of it. The 2 stays on top because it's positive. The x cubed goes at the bottom to undo the negative. And then to undo the negative exponent that is being times by, we're going to inverse the inner expression. The 3 still remains negative because we're just moving its location, we're not doing anything to it. And now that we have this, we can distribute the 3 to every places. When an exponent, it's being cubed or squared or anything, that's going to be multiplication, which could also be seen as this. So x of n to the power of m is in reality x n times m. So 3 times 3 is 9. X to the 9th, -3 times 3. Just gonna work it out here. It's -27. 2 times 3 is 6. 1 to the 6th. And that's the answer. And then I check if I can simplify anymore, and I cannot. So I know that's the final answer. Here for C, we have to find the least common denominator, even if it has these variables. So essentially what that means is that these variables have to be to the same power. So the least common denominator is going to be 6a squared b squared, because even the number has to be the same in order to subtract. And I knew it's a squared b squared because I have an a squared here. I could just multiply this a times another a to get a squared, and I have a b squared here. So I could just multiply this b to get b squared, and multiply this by 3 to get 6, multiply this by 2 to get 6. So the way you show this multiplication is by doing, and you multiply by what the denominator lacks to get here. So 2 times 3 is 6. How is the a squared? So I don't have to put any a's. It only has one b, so I have to put another b to get it to b squared. And then from 3 to 6, that's going to be 2. A to a squared is going to be a, and I already have a b squared, so I don't include any b. And now we just multiply everything. So 3b times 6 is 18b. 6a squared b squared. 5 times 2a is 10a. 6a squared b squared. And since we're subtracting and not multiplying, because these have different variables, they cannot be combined because they're not common like terms. So it's just gonna look like this. And then I notice that I can multiply further. I can take a 2 out of here. And then after doing that, I can just oh wait, sorry about that. I distribute, I take 2 out of everything, so in reality yeah. And then if I could simplify it further, it's gonna be 9b minus 5a over 3a squared minus b squared. Because the reason why I can simplify further is if you look at this, it's basically 2 over 6. And 2 over 6 divided by 2 can be simplified further into 1 over 3. And then if we just want to rewrite it to get rid of the 1 and make it look prettier, be 9b minus 5a, 3a squared minus b squared. And that's how you solve all of these problems. Key takeaway is that when you're dividing exponents, you're subtracting them. When you're doing an exponent to the power of the exponent, you're multiplying it. And when you're subtracting expressions, you have to make sure that they have the common denominator. You have to find the least common denominator. And always double check to see if you can reduce further. So yeah, thank you.